Hello everyone, very good morning. Right, so in the last two sessions, we have seen some theoretical concepts related to transformers. Few things in the theoretical part is left, so I'll quickly discuss that, and mainly we will see the practical part of it tomorrow. And how do we use the transformers? Right, so before I go ahead, I will just give you a brief of what we discussed yesterday, a very quick brief, and then I'll discuss the further part of that. Now, in the transformer, I told you that the concept of transformers started with this paper, research paper, which is called as Attention is All You Need. This is the name of that research paper, which started the concept of transformers, the concept of attention mechanism that we were talking about, which is the foundation of a transformer concept. So that attention mechanism was uh, written down in this paper, research paper, Attention is All You Need, which is created by the people working in Google. And those researchers have created this concept of transformers. Now, transformers is way ahead of the previous tools which were used for the purpose of NLP. Way ahead means much more powerful. So earlier we were using RNN, LSTM, GRUs. These were the three tools which we were using, but Transformers has completely changed the game because of it being much superior than those tools which were there. Now, why is it so much superior? Just because of the reason that we have an infinite reference window. Those tools, RNN, LSTM, they have a very short reference window, means they can't remember the entire text. But Transformer has something which is called self attention. And because of self attention, it has the capability to remember everything which has been given. It has an infinite reference window. So it can remember all the text, it can refer to the entire text to generate the further things, to answer something, or to summarize something. That is the advantage. So it is much better than that. And nowadays, transformers are getting updated every single day to become even more powerful. And transformers, which was created 4 years ago and versus now, there's a huge difference and huge updation that has happened in the transformer itself. So nowadays, they are very, very capable compared to what it was 4 years ago. Now, so I saw shown you that this is the basic structure of any transformer. So one part is about the encoder and one part is about the decoder. We were talking about here, we started the story that first let's talk about the encoder side of the transformer. Decoder side of the transformer is also very similar, just with one or two simple differences. But apart from that, the structure is basically same. So encoder takes a statement, convert that into vector form by understanding the context and meaning of the statement. And then decoder takes that vectors and it start to either translate that or summarize that or generate the further words. Whatever it has to do, it will take that from the encoder and start decoding. Now we saw a few basic things that if suppose I have been given a statement, hi, how are you? What will encoder do? Where will it start working with this? So first we have this box here, which is input given to embedding. It does the embedding. We get the embedding vectors. Then once we get the embedding vectors, which look like this, which is nothing but an array of some size, we add positional encoding with that, with the embedding vectors. So once we have this position encoding with word embedding, so whatever result we get, that is called positional input embedding, and this is given to this. these are the three inputs which is given to this structure from here to here. This structure is our encoder structure. And this part, which is called positional input embedding that we saw yesterday, is given to this box. Now, when this is given to that box, in that box, the very first thing is there, which is when this is given, this is passing through that, and output will be encoder input representation. That will be the output of the encoder. But there, what happens? There is something called as multi-headed attention. The first thing which is there inside the encoder, this part, this box, is multi-headed attention. So first, your positional encoded vectors goes to multi-headed attention. Now, what is multi-headed attention? Multi-headed attention is basically a combination of self-attention boxes. Right, multi-headed attention is a combination of self-attention boxes. So we don't have just one self-attention box, we have multiple self-attention box. And when we combine that, we get multi-headed attention. Now, so if you just talk about that box, if you just talk about this box, just this box. So what things are there inside this box? What happens inside just this box? So that diagram is broken down in a more detailed manner here. So just inside that box of multi-headed attention, these are the steps that is going to happen. So first, your words will be there. Each words, right? Each words will be done what? So each words will be having three things: query, key, value. Each word. So hi, how are you? Each of the words are going to have query, key, value. So when you have this query key value, then what I have told you, what next? So I told you that if this has query key value and the other word also has query key value, and if you have to find out which word is related to which word. So what do we see? We see the similarity between the query of a word with the key of another word. Right. So this tells us in the multi-headed attention, we have self-attention boxes, and self-attention boxes this much from here to here. Right. This much part, which I have written in the blue color, this is the box of self-attention. Self-attention is nothing but just a process trying to understand the relationship between the words of a given statement. Whatever statement has been given. So in that statement, whatever words are there, how they are related to each other. So self-attention is trying to understand that meaning from a word. And we use multiple self-attention boxes. Why do we use multiple self-attention boxes? So the concept is, the people who created this, they said that one self-attention box might not be enough. Let's put multiple. And what multiple self-attention boxes will do? One self-attention will understand, let's say, connection between the words. One self-attention will understand the meaning of the word. One self-attention will understand the syntax of the word. So multiple self-attention if I use, so each of the self-attention boxes will try to understand a different thing from your given statement, right? Like one self-attention can understand just the relationship between the word. One can focus on understanding the meaning of the entire statement. One can focus on understanding the syntax of the entire statement. One can focus on understanding the grammar of the statement. Right. So that way, if you use multiple self-attention, that is much better than using one self-attention. And then what you do, you concatenate, right? You concatenate multiple self-attention. So what first self-attention has understood plus what second self-attention has understood plus the third self-attention and plus the fourth self-attention. What all those have understood, you combine their understanding to get a very powerful and a very intelligent system, which is going to be used in encoder. So encoder has the first most important component in the encoder, which is multi-headed attention. It's a combination of multiple self-attention boxes. Correct? So in self-attention, a very simple thing that happens is just you will have to watch the video of the previous two sessions to understand it in detail. But for now, just a simple idea is that in self-attention, we are trying to understand either the meaning or structure or context or grammar of the given statement. Correct? Now, how many self-attention boxes are there? 6. So there is a fixed number given that there are 6 attention boxes that we have to use, and that will be used in the main structure of the transformer. So this is the number of self-attention boxes which will be there. In encoder part also, in decoder part also, 6 number of self-attentions are used, and they will be combined together to get the multi-headed attention. So we talked about that we have the words, and we go through the self-attention. Self-attention is trying to understand the meaning, relationship, grammar, all of that. So if I take each word, so hi, if suppose this is hi, then this is how, this is are, this is you. Hi, how are you? This is the things. So each word, suppose I talk about hi. So hi will have these 3 things, then how will have these 3 things, then are will have these 3 things, and then you will have these 3 things. Right? And these 3 things are what? Just nothing but they will all have these 3 things: query, key, and value. Each word will have query, key, and value. Now, what does query, key, and value? How can you understand that? This was the thing I have given. You can go through that. Now, we take the query of one word, multiply that with key of another word. And what do we get? We get the scores, that how one word is connected to another word. So what we are doing, you can see there are 4 set of boxes, right? 4 set of boxes are there. So these are 4 queries for 4 words. Hi, how are you? For 4 words, 4 queries I take, and for all the 4 words, 4 keys I take. So when I do the matrix multiplication, I am trying to see how each of these 4 words are related to each of the 4 words given in that, how they are related. So query of each word into key of each word, that is a matrix multiplication we do, and we get something called as scores. Scores are nothing but attention weights, you can say. Scores we are giving, which tells us that which word is very much related to which other word in that sentence. Now, once we got these scores, we have scaled that scores, because the scores can be very large, and if I use those large numbers, I might need more calculations. So it might take more time. So we scale down the scores to a smaller number. And once we scale it down, then we try to convert those scaled numbers into probabilities, right? So when we represent that as probabilities, then that will be much easier for us to interpret that how much is the strength of the relationship between one word with another word. So this is what gives us the probabilities. Now we take that, and this thing that we are getting, we call this as attention weights. Whatever we are getting here, this is our final attention weights. So this part was our initial attention weights, this part. So we scaled the attention weights and then took the probabilities of those attention weights. So this is my final attention weights. So how much attention one word is giving to another word, that is attention weight. Now, we take the attention weights and then multiply with the value of each word to get the particular output. So here, this matrix multiplication is the combination of or multiplication of attention weights and multiplied by the value of each word. And then we get some output. Now, once we get this output, then we don't stop here. Then this entire process that we have seen till now, take the query key, multiply, scale it, and convert it to probability, and multiply that with the value. Same thing will be done 6 times. Same process will be done 6 times on the same input statement. So, hi, how are you? That statement if you have taken. So this process you are going to do 6 times. this much process from here to here will be done 6 times. And once we do the process 6 times, then we understand different meanings of the your encoder is trying to look at a statement in different ways. So what it might tell us, what is it telling us? So it tries to understand it in depth by going through different ways. So that is a better thing to do instead of just understanding the meaning once. Let's look at it from another perspective. So when you look at from 6 different perspectives, yes, this will always be 6 because it is fixed in that entire encoder structure. It is always fixed as 6. So when you look at a statement from 6 different perspectives, then you understand a statement better, and then the transformer can give correct answers, more powerful answers by understanding the statement 6 times from 6 different perspectives. Now, when you're doing this part 6 times, so 6 outputs you're going to get like that, which you concatenate, right? Which you concatenate, and then you apply a linear. Linear is nothing but the same values you are going to get when you pass it through the linear activation function. So what are we getting? We are running this part 6 times. This part, this part of the box is giving this output. So this output will be generated 6 times and they will be concatenated here. And then they will be passed through linear activation function where we will get the final output. Here, at this point, we will get the final output. This is the working of the encoder. Right? Why 6 times? Because it is given in the research paper. That research paper attention is all you need. So they have seen that if you understand a statement from 6 different perspectives, that is enough for us to understand the meaning of any complex statement that we have got. Suppose we have got a statement of 5,000 lines and we have to understand the meaning of that. We have to summarize it. So if you look at from 6 perspectives, that is enough. Less than 6 is not enough and more than 6 is not required. They have found out by research that 6 is enough. That is why they have done that with experimentation. Now, so this was the entire structure of encoder. I hope this would be clear to all of you. At this point, I hope this should be clear to all of you. That we have this self-attention time multiple times concatenated together. Now, one very important question was asked yesterday. Let's say you are working in a company, right? And that company works on any data, like suppose insurance data or medical data, or let's say data related to power plants, chemical industry, and everything. So suppose if you're working for a company which is working in a particular domain, it can be any domain, chemical domain, financial domain, medical domain, or sports domain, any domain your company is working. Now, you want to use these transformers for something, let's say question answering or text generation, summarization. For whatever purpose, you want to use this transformer in your organization. So, 2 options are there. Either I create my own transformer or I use the pre-created transformer. So some companies are creating the transformers for us and they are known as pre-trained transformers. Right now, very interesting thing I'm going to tell you. So what happens in the real world? So many of the companies will use these pre-trained transformer as it is. Right? Whatever they are trained, however they are trained, many of the companies will use them as it is. Suppose there is one transformer specifically designed for finance industry. One transformer is specifically designed for medical industry. Now, so when they have been trained on finance or medical, what does it mean? That they have taken finance and medical data from entire world, from different websites and databases. They have taken the data, millions and billions of data they have taken, and they have trained those transformers to understand any disease or any financial issues they have been trained on. But they are trained on a generalized data, right? They have been trained on a generalized data by taking different data from around the world. Some data from Indian companies, some data from US companies and all. They are generalized pre-trained transformers. But now suppose your company is doing something specific. So what can be done? You can go through a second process, which is said that you take the pre-trained transformer. This pre-trained transformer is going to give you a overall generalized understanding about the medical domain. It has understood how the medical domain works, how the insurance domain work, how the technology domain work, how the uh, any chemical domain work. It has understood the generalized version about the domain. Overall, it knows what happens in the domain. So what you can do now, you can give your company data, right? You can give this company data to this pre-trained transformer and you can fine tune it, right? A process called as fine tuning. So when we use this term fine tune means that I am taking a transformer which is pre-trained, but it knows the general concept about the domain, but I want to make it specialized for my data. So when I give my data, company data, combined with the pre-trained version of it, so it will understand my data properly combined with the overall generalized information it has. So it will become very specialized version of transformer. And this specialized version of transformer, I can then use in my company. And this will be much more beneficial for me as compared to using the generalized pre-trained transformer in my company. Correct. So this is a process called as fine tune it that you will do when you go to the company. And that is what the things will be done. Correct. This is the very important thing. The fine tuning is done. You take the pre-trained transformer because this is important. If you just make your transformer on this company data, the company data is going to be very small, right? That will not be enough to make your own transformer. That will not be enough. So good thing is, or a better thing to do is that you take a pre-trained transformer, which has been trained on billions of data, then you fine tune it and you make it specialized for your company, for your task. And that will be the thing to do. Right. So two things are done. You can use it as it is, which some companies do, or you can fine tune it for your specialized version of the data of your own company. Right. Now, from where we get this pre-trained transformer, that is what we are going to study today. So we have talked about so much of theory. Let's go now to the practical part. And let me show you very interesting things that how can you use these pre-trained transformers for now. Let's take a look at that. So decoder part is left. Few things I need to tell you on decoder. So I'll explain that after some time. Let's now see some practical things and use that. Otherwise, we'll get bored of just talking about the theoretical thing. So I've written down a lot of things for you and you can use this. I'm sharing this collab link. Just click on this collab link. Don't copy this. Click on that and it will open up for you. What you can do, you can take go to the file and download it and then separately upload on your Google Colab, or you can use it directly whatever way you are already using that, you can use it like that. I hope all of you know the Google Colab, the working of it, because you don't do these processes on your laptop, right? So if you do these processes on your laptop, then your laptop will be stuck. It will hang because these processes which we perform in NLP with the transformers, they are very powerful processes. They require a lot of RAM, a lot of memory. So it will be very difficult to use this on your own laptop in your Jupyter Notebook. So we don't use this on Jupyter Notebook. We use it with Google Colab. So here my computer will not hang in this case. Now, so there is something called as Hugging Face. That's the name of a company, Hugging Face. This company is going to provide us with multiple pre-trained transformers. So any company, any other company who is making the transformers, they upload it on this website, Hugging Face. Hugging Face is the main company which is uh, generating their own transformers also, but taking the transformer from the different companies also. Latest models of different transformers will be available onto this website, Hugging Face, and you can use those transformers from this website to do your task. You can download that version, that transformer version. You can fine tune it, right? Or you can as it is, if you want. So for many cases, I can use as it is. With for as an individual, I can use it as it is. That will be much more than enough for me. But if I'm working for a big company, then I will fine tune it. That process will be done. So today we are going to understand how they will be used by us directly. Fine tuning part will be done later. Correct. But as a fresher, you need to know about how you are going to use that. Now, so Hugging Face is the name of the tool. For now, yes, for a smaller version, what as an individual we can do is free. But what organizations are going to do, they will have to pay for that because organizations are going to use this intensively. So that part is not free. But if you're using that for a individual purpose, then we will be doing simple tasks. So for that, it is free for doing the simple task. For learning that, for playing with it to learn that, that is free. But whenever you go to company, they will have a paid version of that, which you can use directly. So company will pay for that. Now, like this Google Colab, you see, Google Colab is also free and paid both. We are using the free version and that is enough for us. We don't need the paid version as an individual. But when we go to a company, then we will be dealing with a very large data and we will need more resources. Now you see what happens in Google Colab, we connect to this. So if I click on this reconnect or connect, whatever is shown here, if I connect that, it is giving me access to RAM and disk storage from Google server. We are not using RAM and disk storage of our laptop. We are taking this resources from the Google server. You see RAM and disk space. So now if you see RAM is, I'm getting 12.67 GB of RAM. I'm able to use, I can use. And 107 GB of that disk space is given. Now this is shared among all the users which have connected to that. So this RAM and disk space that you see is shared among multiple users. But I can use a good amount of RAM and disk space and I'll not be having any issues in that. But now suppose you have to use this further and you are working on a very large data set. So you might need more than 12 GB RAM. So for that, you can have a paid version of it and they will give you a more RAM access, more disk storage for virtually anything that you want to do. So you don't have to purchase a laptop which has 64 GB RAM or 128 GB RAM. You can just take that from the Google, okay, as a rent. So how much you use that, you're going to pay for that as a paid version. Now, so very similar to that, Google Colab is also paid and free. Likewise, Hugging Face is also free and paid. Now, so it is the most popular platform that you're going to use for NLP tasks, for transformer tasks specifically. Hugging Face is the most popular platform. Now, why is it most popular? Before Hugging Face, research was conducted in silos. Silos means alone. So every company was working on their research alone. And it was difficult for the community to access any of the latest model from the hub. Now, suppose one transformer has been created by Microsoft and one transformer has been created by Google. Now, earlier they were using their own transformer. This was using their own for their company. This was using their transformer for their company. And they were not able to share it with others. This was not possible. Now, because of this platform Hugging Face, they upload their transformers, whatever latest version of transformer they have created, they upload it on this website, this platform Hugging Face, and other companies can use that by paying an amount for using that transformer, right? So it is good for the public also that they are getting access to such powerful transformer created by such big companies. We don't have to create our own transformer, and for some small fee you can use that. And also these companies are also able to earn money from that. Correct. We are also able to use them, and the companies are also able to earn money. So win-win for users also, and win-win for the company also. So this platform is going to give us the access of that, right? Yes. We'll see, Rakesh, we are going to that now. I'll show you those things. Now you see, Hugging Face has democratized the research by giving users access to direct state of model. So suppose you are working as a researcher in any institution, or if you're working as a researcher in a company, like if you're in any university or any company, if you're a researcher, so that you can use that thing. Just a minute. Yes. Yes. So you can use this powerful model to conduct your research, and that will be very beneficial for you. Otherwise, if you do not have access to these transformers, so then you cannot perform a very powerful research. But now you have the capability to perform a very powerful research on images, research on videos, research on text. You can perform any amount of powerful research you can perform. And you can create something which was not thought of like 3, 4 years ago. It was not thought of. It seemed impossible, but we can do it now because of the state of the art models that we have available. State of the art means very powerful and complicated model available to us. Now, what we are going to see in this notebook entirely, in this notebook, we will focus on understanding the architecture of the transformer, basic thing that how we are taking use of those transformers, which are pre-trained for us, and we'll be taking a look at that. Now we will see, explore different features and functionalities of this library, of this platform, Hugging Face. We'll see different NLP tasks like text generation, text summarization, different examples I'll show you. And we'll see how to load a pre-trained transformer, how to use that. And we'll see a pipeline. What is a pipeline? Pipeline will take a data, pipeline will take a model, connect them, and give us the result. We'll see these things. Now, in the file that I've given, the very first thing is I've written these 3 things here. Now, this is not required for your Google Colab. You don't need to run these 3 things for Google Colab. But if you suppose are working in Jupyter Notebook on your own laptop, then you will have to install this, and this, all 3 of them one by one, you will have to install in your Jupyter Notebook in your laptop. But in Google Colab, it is already installed. The latest version is already installed. So you don't have to do anything, any installation as of now. Correct. So you can just skip these part. You can start from here, task 1 pipeline. Now see, Hugging Face provides a high-level API called pipelines that makes it easy for us to perform a variety of NLP tasks with just few lines of code. Now, what exactly is a high-level API? Right, what do we mean by API? Yes, Rakesh, you can use any one of them, PyTorch, TensorFlow, TensorFlow 2.0, but one of these things should be available to you, right? But you can use any one of them because it is compatible with all of those tools which is there. It is compatible with that. Like you see, Hugging Face is compatible with PyTorch, TensorFlow, Transformers, TensorBoard, and Keras, and whatever other tools that you see here. It is compatible with all of them. So visually, whatever is available to us, I can use this transformer with almost every package. Now, you see, when you go onto this website, let me share this particular website to you. This is that platform called as Hugging Face. And these are my models, which are my pre-trained models available that you can see. Now, we have in front of us, if you open this website, you will see on the left side, image text to text, visual question answering, document question answering, depth estimation, image classification, object detection, text to image to text, image to video, video classification, image to 3D, image feature extraction. If you talk about text classification or table question answering, summarization, text generation, translation, all the things are given to you on this left side. And if you click on a particular thing, let's say I want to do summarization. If I click on that, so for summarization, whatever models are available to us, see, 1830 pre-trained transformers are available just for the purpose of translation. Some are more powerful, some are little less powerful, but very powerful, all of them. Correct. So you can use any of these models from these 1830 models. You can use any one of them. I'll show you how you use them, but you can use any one of them and you will be able to do a task. So for summarization, these are the models. And if you don't want to do summarization, if you suppose want to do text generation, right? Or you want to do question answering, like you have given some context and you want to ask answers from that. Suppose you have given a research paper, a 30-page research paper you have given to a transformer, and transformer now understand the text. It now understand the entire research paper. Now you can ask the questions from that research paper. So you don't have to study the research paper. You just ask the question. It will give you the answer from that research paper, which I will show you how you can use that. And then you will try after the session. But I'll show you now examples of this also. So if you want to find out what are the models, pre-trained model we have for a particular task, you just go to this website, huggingface.co/models. And you see on the left side, you have all the tasks that you want to perform. Whichever you think you want to perform is everything available here. You click on that particular part, you will see the model names for that task and you can use them. I'll show you how you can use them. Perfect. So this is the library. This is the platform which we are going to use. Yes, yes. For now, you don't have to worry about how do we know which is best. You will get to know that when you're working in a company. Because for now, we don't have such a large data available or such a large task available for now. For now, you can use any one of them. But when you go to a company, when you use it on a larger data and more complicated task, when you're going to perform with this, then you will be able to understand which one is better. Like in this case, there is no right or wrong answer. As of now, I cannot say that this one, the first one is better and second one is not better. It is for different type of data, different models will perform better. Right. So there is no answer that I can give that use this one and don't use that. Because if some model was good and some model was bad, so bad one would have been removed from this platform. So there is no right answer, wrong answer. The thing is, if you click on question answering, you can use the ones which is available and you can use them. So they will all give you good enough results, satisfactory enough results. But now you can search that which one of these models have been created very new, very latest. Right. So you can search on the internet for question answering, which is the Hugging Face model, pre-trained model, has been created latest. So suppose you get to know that this Explore with AI Jarvis is the latest one which has been created. So you can use this one because this has been created latest. So you'll have to just basically do a simple Google search to find out which one is latest and you can use that. Right. But for now, just you can use any one of them. And if you click on any one of them, it will give you a detail about those things which is available. Correct. You can use this. It is giving you the code also, how to use that, right? How to use that in transformers, how to use that in PyTorch, and all the code. You have to just copy this from here as it is, and you can use that. But now let me explain how this thing is going to work so you can make use of any of the models given here. Right, the code is given. You just have to copy paste that and you will be able to use it as it is in your Google Colab without any changes. As it is, you can use that. Let's see. So task one is pipelines we are going to use. We are going to talk about the pipelines. This is the most fundamental thing to know about the Hugging Face lab. So pipeline is high level API that we have, and we will be able to use that. Available pipelines which are there are for text generation, text classification, question answering, summarization, translation, fill, mask, NER. These are some of them I have written, but if you want to know the entire list, what are the tasks can be performed? So you can see on the left side, a complete list of all the tasks is given here. But here I've written some of them which are commonly used, like generation, classification, question answering. These are commonly used tasks. So I have written that here. Let's start the main part from this point. So first task, we are going to see how can we do text classification using pipeline. What do we mean by text classification? So we are trying to understand whether it is a positive statement or negative statement or a neutral statement. We'll try to see that. We'll try to classify a text into one emotion kind of thing. So now the first line here is import warnings, because if our code is showing any sort of warning, I just want to ignore that. This is one line. Warnings are nothing but warnings are something which is telling that you have not used this or you have not used that. So it is not very important. The warnings are not important for us. We can ignore that. Sometimes it is because we are not using updated version of some package. So it is not very important. I can ignore the warnings. Main part starts from here. The main code starts from here. So this line of code, from transformers import pipeline. So transformer is the name of the library, the package from which we are using this function pipeline. And this is going to Hugging Face platform. It is going to Hugging Face platform. And there is a package called as transformers, inside of which there is a function called as pipeline. We are using that for the purpose of classification. Now, first thing what we do, we load the pipeline. You see, I want to use the pipeline, this pipeline, and from the pipeline, I want to perform this task, text classification. You write like this, exactly like this, small text, dash classification. You say that, take this pipeline, perform this task. I want to perform this task. Now you save that into a variable classifier. Basically, you're loading the model into this variable classifier. Now you take this variable classifier and give a statement, any statement. You can play with this statement. I've just written a statement, I love India. And when you take this classifier, I give a statement, it will classify that into negative, positive, and it is going to save that into a variable result, the answer, positive or negative, and we are printing that result. So when I run this particular code, you also can run this code. As you run the code, you will notice now it is trying to load that transformer. It is trying to load that particular pre-trained transformer. And now it is going to take the statement I have given and it is going to classify that into either, you can say, positive or a negative statement. So now it is saying that this statement that you have given is a positive statement with, it is saying that with 99.98% accuracy, it is this much confirmed, it is this much sure that this is a positive emotion, positive statement. It's not a negative statement. So you can try giving a negative statement like a hate comment you get or a hate post that you get on Twitter, LinkedIn, anywhere. You try different statements and it will tell you whether it is a neutral statement, positive statement, or negative statement. It will tell you that. Now, so I have taken the model here, loaded that into this variable. Then I use that variable, given my statement. It gave us the answer. The answer I have stored it into this result variable, printed. Simple 3 lines of code that we have. Now let's see, instead of one single line, you can give a longer line also, longer statement also. You can try with that. Now, yes, I'm coming to that. So it is saying that no model was supplied means that it is using the default one. But it is recommending that instead of using the default one, you should give a particular model name. You should give a particular transformer name, pre-trained transformer name. So like multiple names are here available, like this deep C coder V2 instruct. So you should give name of a particular transformer which you want to use. Otherwise, it is saying that I will use the default one, and maybe default one is not good enough for your task. So instead of using the default one, please mention which model you want to use. So I'm just coming to that. So you can write a particular parameter here, model is equal to, and give the name of that particular model, which I'm going to show you just in 2 minutes. So it is saying that no model was supplied. That is the thing. Now, there is a thing given here. You can understand the output, but you don't have to go all of this. Just basic idea is that we have taken the pipeline, which is a function. I have used this text classification. I loaded that into this variable classify. So model was loaded and I used that model and I have given this statement and I got the result, which I printed. Now let's see. We can pass multiple statements also in the text classification. Like I have given one statement. So instead of one statement, you can give two statement, 200 statement, 2000 statement, 2 million statement. You can give multiple statements and it will classify all of the statement one by one for you. So you don't have to do that thing again and again. You have to copy this code again and again for different statement. What I'm doing now, I'm making a list of statements. So first statement, second statement, you can add more. After the comma, you can add more statements here. So I have given some statement. Now your model, I'm loading my model again, pipeline with text classification. I'm loading that into this variable and I take that model. I give this input sentences. Now this is a list of sentences. I give that and I get the result. Now result I'll get will be multiple because I have multiple statement. So result will also be multiple. See the result. If you run this code, it will show you that the first one, the first statement, I don't like this movie, is a negative statement. And it is this much sure that that is a negative statement. It is not going to be ever 100% sure because there is always a chance of making an error by the model. So it will be 99%, 98% sure, but it will not be ever 100% sure. So it is saying that with 98.39% confidence, I can say that this is a negative statement. And second one, it is saying that university is helping me learn new and wonderful things. So that's a positive statement. With this much accuracy, I can say that this is a positive statement. So likewise, you go ahead and add multiple statement into this list and you can see the results for each of them one by one. Now, we have just seen the most basic example. We have statements, the model being loaded here and stored into this variable classify. I use that word classify, which is my model, loaded model. I give my statements and I get the result. When I print the result, I see this answer. This is my final answer, this part of the thing. The above part, those two things you don't have to see, but this one you have to see. Only two categories available, you see. Not sad and assertive and confident, you see. When you are going to use that, so that is if you're talking about those sentiment. So for that purpose, there is another particular model, like I am trying to do text classification. So text classification will not give you sad, confident, or assertive. That is the work of what? Sentiment analysis. So there is a particular task called a sentiment analysis that will give you more about the sentiments. So somewhere it should be mentioned, sentiment analysis. Where is that sentiment analysis? I'll see in any one of them, it should be there. I'll see in which one it is there. I'll mention that to you. So that is the work of a specific thing called as sentiment analysis. Now we have text classification we were doing. Okay, in that. Let me see. What is the model for the sentiment analysis? I'll check that and I'll tell you now. Yes, you try giving a neutral statement and see what it is telling you. It can also tell you neutral if it is a neutral statement. So in this, you can try just change this statement to some neutral statement, and you see what it is telling us. see the output and play with that. That is what will help you learn. Now, so what we have used here is we have seen a list of statements. I have loaded the default model. Here we have loaded the default model and we use that. But now let's load a specific pre-trained transformer model, specific one. So for using the specific one, what I'm now going to do is I am saying pipeline text classification, this much I was right. But now if I have to use a specific model, I'll write model is equal to Roberta base I'm using. Right, I'm using model is equal to Roberta base. From where it is coming, from where the name is coming. So if you go and if you search for Roberta base, Roberta base, you see, for Roberta base that you mentioned, Roberta base Go emotions, Roberta base OpenAI detector, Roberta base emoji, Roberta base irony, Roberta base sentiment, Roberta base language detection, or Roberta base fine-tuned damping Chinese. Different models are there for Roberta base. And if you go ahead into other pages, so you will also find out multiple of them. You see so many things are there for Roberta base. So many models are there for Roberta base, and you can take a look at that. So which one we are using? We are using this base one, which is Roberta base, just Roberta base. Okay, base one. If I have to use Roberta base IMDBFT, then I will mention this name, Roberta base IMDBFT. Correct? So now you can see we are using that particular model from there. For now, I'm using this one. And now see, I'm not using the base model. I'm using a particular model. I'm not using the default model. Change that name. So once I mention that name and I run it now, you see what it is telling us for this statement, I love India. Let's take a look at that. See, it is telling us something called as label 0, or it is going to mention something's label 1, label 0, something like that. It is going to mention that. And it is only 50% sure that this is the answer. Now, what is label 0? Is it positive? Is it negative? I don't know that. It is not telling us whether it is positive or negative. It is just saying that that statement is something like a label 0 with only accuracy of 50%. It performed very bad, which means that this particular model is not suitable for this type of text classification. The one which we have used before was more better. Like which one we have used by default? You see, by default, this model is being used by default. Distilbert base uncased fine-tune SST to English. This is the name of the model which was used by default for the text classification. It had performed very well, brilliantly. But when I'm using this particular one, it is not giving us very good results. And it is giving us inaccurate results also because it is not suitable for this type of task. So we have to see for what type of task a particular model is there. And I'll mention a cheat sheet. I'll give you a cheat sheet. I'll upload that on the drive, which I shared yesterday. And that using that cheat sheet, you will be able to see which model are used for what purpose. And that will be easy for you to follow. But for now, just I want to show you that if I use a particular model, which is not suitable for the task, so it is performing very bad. So you will see either label 0 or label 1 will be shown to you. When you run your code, either label 0 or label 1 will you see. So it is saying that this label 0 or label 1 is not specific to any particular sentiment. Rather, it is general label that model assigned to any one of the possible classes for the sentiment classification task. Right. The reason why the score is low for the sentence I love India when using Roberta base model is likely due to the fact that this model was not specifically trained on sentiment analysis task. Correct. So in this case, what you are saying is this label 0 is not telling you a particular sentiment, like is it positive, negative, neutral. It is not telling us any particular sentiment, right? Now, why is it not telling us particular sentiment? Because you see, this is not specifically trained for sentiment analysis task. But the previous default model, this was the default model which was used, that is trained on a sentiment analysis task. But this one is not trained on sentiment analysis task. Now, let's give it, in the previous one I was using. So let's give that a sad statement. Let's see whether it is going to give you that emotion or not. I am sad that India lost the cricket match. If suppose I write that, I am sad that India lost the cricket match. Let's see, is it giving us the sad emotion or is it telling us negative in that case? You see, it is telling us negative. So for now, this text classification part is giving you negative or positive. But if you want to get the other range of emotions, I'll tell you which particular model is used for that. I'm forgetting that name, but that will give you the entire thing, right? Entire sentiment. Is it sad? You are angry, or you are anxious? What kind of statement is that? It will give you a sentiment analysis for that. Now, till this much, are you clear? The three examples I have given to you. You play with it. You try different statements in that. I hope you are able to understand. Simple 3 lines of code is there in all of them, and you should be able to understand. Simple thing. Now, after that, let's see another example, text generation. How can we generate the text? One pipeline we have seen for text classification. And now we are going to see one example for text generation. How can we generate the text? If I give some statement and I tell it to generate the further words in that, I tell it to complete it. So how it can do that? We'll take a look at that. But let's take 5 minutes of break and then we will see this fresh. Till the time, you can change this statement here and you can practice this thing. You see, this is the statement I've given and I want that after this away, it should generate the further text. So change the statement here. You can try like, I love India because, or I hate cricket because, or I hate football because, or I hate wars because, something. You give it a prompt and see what it is generating for you here. By the time you can, if you want to play, you can play. Right? Now, no, pipeline is the name of a function. This function is running the pre-written code for us, right? And you can say that this process is a pipeline. Pipeline is you have a pre-trained model and you're giving it a data, right? You have a pre-trained model, you're giving it a data, so it is creating a pipeline. Correct? What is a pipeline? Pipeline is, you see, a pipe where you send something from one side and there is something in the pipe and then you get something outside. So what is there in the pipe? In the inside the pipe, you have the trained model, right? Why do we call it pipeline? Because in the pipe, you have the trained model and you are giving your text. So whatever text I'm giving, it is going through a trained model pipeline and outside we are getting the sentiment of that or text generation, summarization. I'm getting that as an output. But what exactly is there in a pipeline? Just one trained model is there. Trained model is consisting of multiple steps. I'll break down the steps for you. What exactly is doing when it is going to the pipeline? There are 4, 5, 6 steps which is there, which it is going through inside the pipeline. Those steps also I'll show you. But this text is going through some steps, then it is able to tell us whether it is a positive statement or something like that. Now, we'll see. Okay. I'll show you that part. What is there inside the pipeline? Yes, yes. I'll show you the code. What is the code inside these models? I'm coming to that. I'll show you a broken version of that. If you don't want to use this pre-built one, if you want to do these steps one by one manually, so I'll show you that part also just after this. Okay, let's see this text generation part using this pipeline. So this pipeline that we are able to use, it is not just one single step. It is a collection of many steps which is being done to give you the final answer. But we are using this pipeline to make it easy for us so that I don't have to write a lot of code which is already written by someone. So I'm just using someone's pre-written code and I'm able to use that pipeline so that I don't have to write much of the code. Correct? But it is having certain steps which it is going through to give you the generation. Classification, generation, summary, whatever it has to do, it is going through some steps which I'll show you. Now, in this case, I have a pipeline. Correct? I've already given this file. I'll upload this on the LMS also. So I've already given this for now. Now, here we have the pipeline. In the pipeline, I was using text classification earlier, but now I'm using text generation because I want to do text generation. So I mentioned the task that I want to do using the pipeline, and I'm mentioning a particular model using which I want to do this task. So there is a model by this name Distill GPT. I'm using that for the generation. You can change the model name by going through that package. And you see now, for now, just use this as it is. You see, I'm taking the generator because this model that I'm using, I'm loading that into variable generator. Then I use the generator, I give my statement, and it is going to generate the further statement. So suppose I run this code. When you run this code, it is going to generate whatever it thinks on the basis of these given words. Let us see what does it generate. So I have given in the galaxy far, far away. Till this much I have given. You see, after that it is generating the words. So we can only see the galaxy far away from the sky. It is a bit more fun now, so you can't just you just can't imagine what would go into galaxy far away. It's just a random statement which it has generated on the basis of this given prompt. Now, if I change the prompt here, if I give a different statement, it will generate a different text for us in this case. Now, whatever statement is being generated, that is also dependent upon the model that we are using. It can be the case that this is not a very powerful model. So it is not generating a very good text for us. So I can change this model to some other model and maybe that gives us a better generation for that. Now, how can this be used? If you're suppose writing something, you're writing an article, you're writing something, and you don't know what to write further, you're not getting a particular idea for that. So you can give whatever you have written till now, and it will try to generate the further things in that to help you. At least you can get a context of what to write further. You don't have to use this thing as it is if you don't want to. Sometime you can use it, but sometime you would want to manually modify that according to your knowledge. So it will give you some idea, then you can modify those statements to generate the further things in that. Now you can play with it. That is upon you for now. This much you have to know in the generation. Now, we have this masked entity prediction using pipeline. Now, what is masked entity prediction? So here I'm using pipeline and I'm mentioning the name of different task, which is called fill mask. It is saying that you are going to mask. What is this masked word? This is what we have to predict. What should be there? What should be the word present here? We have to predict that. So you are going to this about a wonderful library today. So what should be the word that should be filled here at this place? We are going to find out that. We are going to predict that. So we are using pipeline and the fill mask, and we are storing that into unmasker variable. We take that and we give this, and we are mentioning top k is equal to 2. Top k is equal to 2 means that it can predict multiple words to be put here, right? It can think of, let's say, 5 different words it is thinking that can be put here. So out of those 5 words, which are the best 2 words it has thought of, which can be put here? Show me top 2. If I said show me top 3, so it will show you top 3 words which can be put here, and you can decide which one is better. Now, it will tell you also which one is better, with how much probability. Like if I run this code, you see it is giving us this result. This is the result of that code, which is the first part is from here to here. And it is saying that the token string is the word here, right? You're going to hear about a wonderful library today. That is one word that can be present, or you are going to learn about a wonderful library today. That can be the word that can be put here. But now, which one is with more probability? So it is saying that this word here is with this much probability, that there is a 56.79% probability that this should be the word that should be filled there, and 22% probability that the word learn should be put there. And there, the other probabilities like 56.8 plus 22.8. So it is not 100%, which means that there are other words also which it can give, which has lesser probabilities. So whichever has the highest probability, that will be the word that will be filled at that place, which you can use. Correct? And this is what a masked entity prediction. So you can give multiple locations where the word has to be filled, and then it will fill those words and tell you with what possibility that word should be filled with. Now, remember that all of these things depend upon the model that you're using. Everything, because a certain model has been trained on a certain type of data. So let's say a model has been trained on bad data or less data. So the answers also is going to be according to that. So we need to understand which model is better for us. I'll give you something regarding that to help you. But more of that, when you work in a company, you will understand that for your company's data, which model is working better, that those things you learn. But it should always be understood to you that anything which is being done by these pipelines, it depended upon the type of model you are using. Now, this is task. Next. And then next task is question and answering task. Let's do a question answering task. In this case, I am using the pipeline and I'm mentioning the task name, question answering. This is the name of the task. From here, I've just generated a random statement from here to here. It's a random statement. You can give here any statement, a bigger paragraph you take from some website, you paste that here. So you select from here to here, remove that and paste another statement if you want. For now, this is just an example statement I'm taking. And from here, you see a lot of things are mentioned. Now I'm asking a question, how is Izmir city? So here in this statement, it is mentioned that later my family moved to Izmir, a beautiful city in the Aegean coast, known for its vibrant culture and historical sites. This is said about this word Izmir. Izmir is a city in Istanbul, in Turkey, I guess. So it is there. And it is telling us that what it is about. Again, right? Now, yes. Question to be asked is on the basis of the context. So why are we using that? Because I have a very big statement, paragraph. So suppose I have thousand lines of paragraph I have, but I don't want to study the entire paragraph. I want that this model should take the paragraph from me. I'll paste that entire paragraph here, and then I'll ask the questions from that entire thing which I pasted. So whatever context you have given here, you have to ask the question from this context. Now, like this, some websites have also been created. On those websites, you can go and ask a question. So there are multiple contexts which are loaded parallelly. Correct. There are millions of contexts which are loaded parallelly. So if you go to those websites, then you can ask any type of questions and it will go to that particular context and it will give you the answer from that particular context if you ask a question. But for your task as a individual, or if you're working in a company, you have a data or you have a statement, you give that and you can ask the questions on the basis of that. Right now, this is the manual part we are doing, but this same thing can be implemented into a website or an application, and you can ask the question from the application or website, something like that. Right now, so if you go to that chat gpt can be thought of as a bigger version of this pipeline, question answering pipeline, because you go to chat GPT, you don't give the context in many of the cases. Just go there and ask a question, right? When was the World War One fought? Between which countries were involved in that? Who won? Who lost? What were the things in that? So you have not given the context. Chat GPT is searching for the context in the entire internet, in the entire data on it in which it has been trained. So this is the context. But if you suppose want to do something for your organization, correct, Kishore? So if you suppose want to give a context of your organization, what your organization is doing, it can be related to medical insurance or anything like that. You can give that particular context and you can ask a question regarding that context. So that will be like more fine-tuned version of that. Correct? That will be more fine-tuned version. So you're not asking a question from the internet, on the entire internet. You're asking this thing from this. Right? Now, larger data means, you see, you go to any website, like I have a website here. You are studying about something. Like you can just go on a website which you want to ask question from. You can copy this statement like this from here and go here and paste it. So try that with any website which you want to uh, study. Go to any website, copy the statement and just paste it here. Just paste that. And then see what is being told about that and ask a question regarding those lines of statement. Just that much you have to try. Go to any website, take any article. You are studying a book. You have a PDF of the book on your laptop. Copy some lines from that PDF, from that novel, from that book, and then paste it here and then ask questions regarding that. Right. There is no limitation of the large data. No limitation. It is like infinite we have. Yes, you can give the entire novel to it also, and it will be able. But for now, it will be too much for tasting the entire model. So we'll be seeing how to do that. I'll give you that version, how to give the PDF, entire PDF. Yes, see, these are the things which I'm telling you for now. We are going through a simple example, but as you move forward, you will see a more detailed version of that, how to give an entire 100-page document and ask questions regarding that. How can you give 100-page document and summarize that document? So we'll be coming to that. In this file itself, I'll mention some versions of that. But for now, we are trying to understand because many of the people are right. Many of the people are very new to this. So I am trying to go very simple for now. But of course, I'll add more context, like how can you upload PDF into that? How can you upload a document of 100 page and all of that? That I'll give it to you. And also it will be shown in the further sessions. Today, we are just trying to understand the basic version, how the pipeline works, so that at least you have a basic version, you can play with it. You get an idea overall how things are done in the real world. You get an idea of that. But of course, we are going to go through that also further. For now, you can paste like 100 line of statement. You can paste it here and you can then ask questions if you want to play with that. Correct? Now, so this is the thing. What is being done here? I'm using a pipeline where I'm using this task. I'm loading that into this variable QA pipeline. Then I've given the question, the context, and then I'm saying take the QA pipeline, the variable in which I've loaded the model, then question and the context. Give you that, and then it will give you the result. So the answer is, when I was asking, how is Izmir city? So Izmir city is a beautiful city on the Aegean coast. So it is thinking that this is the answer for that particular question. And this is giving us the answer on that. What is the model being used? It is showing that it is using the default model whose name is this. Distilbert base case distill squad. It is the model being used by default because we are not mentioning any particular model. Now, let's see another example. You see, I have one more example given here where I've given a little bit bigger statement. So I generated these statements from somewhere. Like I can go to, I have one tool with me, which is one type of chat GPT. That website's name is perplexity.ai. So on this website, I can just ask that give me a context And I can just go here, give me a context of 100 lines regarding, you can say, medical domain for the purpose of, what you can say, question answering. For the purpose of question answering in Hugging Face library. Now I'm going to one of the tools of AI, ChatGPT or something like that. It is very similar to like ChatGPT, which name is perplexity.ai. Now, when I'm running that, it will give me a 100-line context, which I can use it there. So it is going to generate a 100-line context from medical domain, and I can use that. You see, it is saying that here is a 100-line context paragraph regarding the medical domain for the purpose of question answering in the Hugging Face library. Now it is generating that entire thing, 100 lines of statement, and you can use that here. It is also generating the code for you, and you can see it is saying that this is the pipeline using this question answering. This is the question you can ask. And in this context, it is mentioned the entire statement, the 100-line statement is being put into this context. You can just do a simple task of copy this, go here, and you can see a copy. Click on copy. The code, entire code is there. You just go, make a new cell, paste this thing, simple, just copy paste, and now run this thing. When you run this thing, you don't have to write even single line of code. That is how you can make use of tools like ChatGPT to generate these code. If anyone want to take any subscription of any of these websites, this is one very good website, Perplexity AI. It's very, very good. Very, very good. The benefit of this website is, I'm just giving a suggestion. It's not anything. You can prefer whatever you want. You have ChatGPT 4 Pro and Gemini. You have Claude Opus is there. So you can see there are multiple versions. This website, the benefit of this platform is that it gives you collection of multiple subscriptions in one. So in this Perplexity AI, I have subscription of GPT also, Gemini also, and total 5-6 models are there. I am having access of 5-6 pro models in one website. So this is the benefit of using this perplexity.ai, and this is very good, very, very good. You can ask any questions, you can use any model that you want. In the settings, you see at the bottom, if you go in the settings, you have the option to change the model which you want to use for this. Just one thing, if you suppose want to use any of these things, this is the one you should use. Now, so you can see now you are able to get the idea that how I can give a statement and I can ask a question regarding that from this statement, and you can see it is telling what will be the answer of that question. It is giving the answer. So the better your questions, the better your context, the better the answers you're going to get. So your answers depend upon how good your context is, how good your question is, and how good a model you're using. On these three things, your final answer is going to depend. Now play with that. Next is text summarization. Text summarization is a place where you summarize many lines of statement. You can summarize. So if you are reading an article and you are not able to understand what it is saying, it is too difficult, give that statement here, like 100 line of statement I have given here in this case. So I can use this 100 line of statement here at this point. I give the text and I say that summarize. I also have the option to mention these things, maximum length and minimum length. Like summarization should be done in how many words, minimum and maximum. So it is saying that whatever summary you generate, that should be at least of 30 words. Don't give me a summary of 20 words or 10 words. Give me a summary of at least 30 words. You can mention the minimum and you can also mention the maximum, and it is going to give the summary. When you run that, so there is a very big statement I've given here, and it is giving a summary of that. It was about startup funding and all. So it is saying that startups are nascent business entities founded by entrepreneurs with innovative ideas. Initial funding come from the founders saving, family, friends. So from where the startups get their initial funding. I have generated a prompt regarding that. So it is giving me a summarized version of the statement which I've given. As the startup grow, they seek additional funding from venture capitalist, angel investor, crowdfunding platform. It has given a very beautiful summary of that. Let me show you how bigger a statement I've given to summarize that. You see, I've given this much bigger statement. You see, so many lines, around 20 lines of statement I had taken. And these 20 lines of statement, I gave it to that text summarization, and it has given a very simple and easy to understand summary of this entire thing. And it is saying that these startups are nascent business entities founded by that initial funding come from there and there. And this was the entire statement I've used. So it's a very good version of that I'm getting, a very good summary that I'm able to see from the statement. You can, like I said, try with a bigger text and see you would be getting a very good summary. You will be able to use that for now here. Okay, so this was about the text summarization exam. So we have seen multiple of them. Let's go once again quickly. What we have seen, we started our discussion here with the pipelines. Pipelines is the main thing that we are using for pre-trained models to be used. First one, we talked about task 1.1, text classification. Simple 3 lines of code from here to here. That is my 3 lines of code, simple. First line, loading the model. Second, taking that loaded model, giving my statement, and then getting the result, printing the result. Simple 3-line statement. Then we saw an example of how can I give multiple input statement. That example. Then I have shown that how can you use a different model. So model parameter you have to mention and name the model. I'll give a cheat sheet regarding this. And then further I saw that how can we do text generation. So I have to mention a text. It is going to generate the text according to this pipeline that I've used. Then if I go through this masked entity prediction using pipeline, so this was the 2 line of code for mask entity prediction. And then I move to the question answer. This also question, context, and this is my pipeline. So in my pipeline, I'm giving the question, the context, and it is going to give me the answer regarding that. Now, same another example is there. And one more example is there. 3 examples are there for that. And text summarization was the last thing we were talking about, where I give a text and I get the summarization of that using this Facebook BART large CNN. If you copy this and if you paste it here, okay, so it is about which one? It is for text summarization. So where is text summarization? You see, which model we have used? So this model particularly by the name of Facebook/BART large CNN, right? And if I'm using that, you see, I have mentioned the model is equal to Facebook/BART large CNN. As it is, I have mentioned the name and I'm able to use that. If you want to use this second one, Phil Schmidt BART large CNN, you can copy the name from here, or if you suppose you go inside of that. Yes, if you go inside, it will give you that particular code that you can use this. Take the pipeline, summarization is the task, and this is your model name. Just copy this thing from here. If you want to use a different model, just copy the thing from here and just replace this part from that copied part. What do you have to replace? This part you have to replace. Simple thing, again, understand. What you have to do, you have to go onto this website, huggingface.co/models. Right, just a minute. I'm again giving that to you. This is the name of the website. Bookmark this website name. And you have to go onto this website. You can see multiple tasks. Click on a particular task. What do you want to perform? You want to do summarization, text generation, sentence similarity, translation, whatever you want to do. Suppose I was talking about question answering. I click on that question answering. Once I click on that, I get multiple models here. Remove this name. I have around 11,493 models in the real world. These many pre-trained transformers are there for question answering. And I want to use any one of them. Suppose I want to use this second one. I click on that, right? I click on that. And now you see, you are going to scroll at the bottom where it has given the code. Okay, let me show you another example. Let's say this one. Yes, now you see here. So here we have the pipeline name, where you have to copy this part from here to here. This part you need to copy. Where you have the pipeline, the name of the task, comma, the name of the model that we are using. Now there is one more thing which is called tokenizer. What is this tokenizer? For now, you can skip this tokenizer part. You can just mention from this part, which is the name of the task you want to perform and the name of the model. Till here you can mention. Ignore this tokenizer part for now. I'll explain what is this tokenizer. But these two things you should be able to use. So open up any particular model, copy that and try that. This is how you will be experimenting that for now. So you can just go ahead and try any one of them and see whether it is giving some different results, some better result than the other model. Play with that. That will help you understand these things more and more better for now. Right? So text to image also it is possible because you see those things are given here. So how you have to use that? If you have to text to image also should be there. You see here it is in computer vision part, text to image is there. So you click on that and you will be seeing multiple models for that. Stable diffusion 3 medium. And if you go to that, you would get the entire architecture, structure, multiple things inside of that. So you need to see if there is something that needs to be installed or something. So you need to have a look at that. Right. So what it is now, if you use this particular code, it will show you a cat holding a sign that says hello world. So you are going to get an image regarding that. But you need to understand, is it asking something to be installed in particular? You can take a look at that. Shekhar, that part I've not shown you. That part will be discussed later. That fine tuning part on our data will be discussed later. For now, we just need to know that. So in some upcoming sessions, you are going to see that part. Okay. For now, we are focusing on how to use the pre-trained model for today. Okay. The task is very similar. Like how can we give our data? Very similar. Before we start this transformer part, we will be loading our data set. Like if suppose my data set is there in a CSV file or in a notepad file or any databases. So before I start this transformer task, I will load the data and do some processes. Then I can use these transfer on my loaded data. So what will happen? You see where I started the pipeline part. Before that, I will load my data using pd.read CSV or pd.read Excel or pd.read SQL. We will be reading our data. Then we will do something on that so that my model learns my data and then we'll be able to use that for further tasks. So that will be shown later. For now, we are using this pre-built one for today to understand the idea about for now. Now, so I hope this part should be clear to all of you. This much is different examples I have shown you. You can try more examples. I have also shown you how to try different example. I hope that also would be very clear to you. Just go to that, go to a model, copy the code, try the code as it is. You don't have to change anything. What you have to change is the text or questions you change from that code. You will be able to try it. Now, I am going to show you one thing which you don't have to understand. You don't have to remember this part, but I just want to break down the pipeline for you. Since you are studying this transformer, you need to know the background thing also, that what is happening when you're doing a text classification, text summarization. what are the steps being done? I'm just going to show you a simple example of that. What are the steps being followed for that? Don't have to worry. You don't have to, if you're not able to understand this entire thing, no worries. Uh, Whatever we have done till now, that was the main task. This is just something extra I want to show you. Now we are going to take a look inside the pipeline with the TensorFlow API. Right. So yes, I'm coming to that question. Remind me after a few minutes. Once I complete that, remind me. I'll tell you that also. Now, so we have this looking inside the pipeline with TensorFlow API. Now, this is the thing. So what is there in the TensorFlow API? Like what is there in exactly in this pipeline? I'm just saying that take a pipeline, do the summarization. But what are the steps being done? If I give a statement which has to be summarized, so what it is doing first, then what it is doing, then what it is doing, then what it is doing. How am I getting the final answer? Let's go through a one by one step versions of that. So it is saying that in the pipeline, there are three basic things available. Pipelines are made of a tokenizer, a model, and a optional pre-processing step. Any pipeline that I'm using, which I'm just saying that use it directly, it is built using three things: tokenizer, your main model, and your post-processing, some post-processing that might be required. And overall, these are the steps being followed. You give your data, the raw text, which you want to classify, summarize, question answer. So you give this text. It goes to a process called as tokenization. Your text is going to be broken down into tokens. We have seen the working of the transformer, right? We break it down into tokens, embed that, or do a lot of things in that. So in a simple way, what is happening in the pipeline is you are giving your statement. Suppose you are giving this statement. Now this statement goes through the first process, tokenization. Always the first thing done is the tokenization. In the tokenization, first your raw text is broken down into list of words. This, comma, course, comma, is, comma, amazing. It will be created into a list of words. And then those words are going to be converted into something called as IDs. Those tokens which are there, they will be converted into token IDs, which are going to uniquely identify a particular token, right? And you see now, so you have 101, then this, and then 102. So now, what are these tokens saying? You see, 101 is a token which is telling you about the start of statement, right? Where the statement is starting. So the number, the ID 101 specifically is used to represent start of the statement. And 102 is representative of end of statement. So that your pipeline would know from where your statement is starting and where it is ending. So these two numbers you have to just know, 101 and 102. 101 for in starting of the statement and 102 to represent the end of the statement. And whatever is in the middle of that, those are the input ID, token ID for different tokens. Like one for this, one for course, one for amazing, one for is, and one fifth one is also there. Maybe there was a comma or something for which it is showing this number. Now, those input IDs are going to be converted into something called as logits, right? So whatever input you have given, it will be converted into these two numbers. Now, what exactly are these two numbers? These two numbers are nothing but it is the possibility. Correct. I have given this. This course is amazing. Suppose this is a pipeline I am saying for text classification. So first I take my statement, convert it into IDs because my model cannot work with text. It has to be converted into numbers. So we are converting our text into numbers. Now this numbers is given to the model here. This number is given to model and I get this. This is called logits. What is this logits? Logits is nothing but a probability version of something. Not exactly the probability, but it is similar to something called as probability. Like it is saying that what is the possibility that this statement is a negative statement and what is the possibility that this statement is a positive statement. Correct. What is the possibility that this is negative and how much is the possibility that it is positive. So you are going to get this logits, and logits when you get, then you are going to use a softmax, right? You will be going through a post processing which is not written here. So this logits, this data will be given to a post processing where you are going to apply a softmax function basically. And this softmax function will give a probability for these numbers. Minus 4.3 that you see here, minus 4.3630 and 4.6859. It will convert these two numbers into probability. Let's say it has converted this number into 0.9989 and it has converted the second number into 0.11. And that you see is showing that it is positive. This much is the percentage of positive and this much is the percentage of negative. And how it is happening, you are taking the logit, giving to softmax function. Softmax function will make it as probabilities. And once you get the probability, then you can get the final prediction that what is the possibility that this text is positive and what is the possibility that this text is negative. Whichever is the larger, it will show you that result finally. So from these two, the final one is this, which is the maximum, and you're getting this result. Once again, what is happening in the pipeline? Pipeline takes the raw text. Raw text is given to tokenizer. Tokenizer convert that into a list of words, which we call it as input ID. This is going to look like this. 101 is a word for start of statement. 102 is for end of statement. And the middle words are for each of the word that you see. Middle IDs are for each of the words. Once you get your input IDs, then you give this input ID to your model. Your model is going to give something called as logits. Logits are these numbers. They will be given to post processing where they will be going through a softmax function. And then you are going to get the predictions. Predictions in the term of probabilities, and whichever has the higher probability, that will be shown as the final result to you. With this, I hope the concept of this is also clear, that what is exactly happening in the pipeline, how you're going from the statement to the final answer, that also should be very clear to all of you. Now, I have the code also mentioned in the bottom. Let me go through the code. Like I said, you don't have to worry about that now. You can take your time to understand that later. But I just want to show you the code. You see, first thing is tokenization. First, I have to do the tokenization. So for tokenization, I'm using this class. I'm taking this class, or I'm importing this class from this particular package. And I'm saying auto tokenizer dot from pre-trained. So I'm saying you have to use this auto tokenizer from pre-trained. This is the thing you have to write. And then the name of the tokenizer you have to mention. What tokenizer you are using for this purpose, you are using that. For now, you don't need to worry about this tokenizer. You can study about that later. More examples will be shown to you. But there is different type of tokenizer also available, which might be good in different cases. So this is the name of tokenizer that we are using. So I will be using this tokenizer to convert my words, my data into tokens one by one. So I'm loading the tokenizer here. In this cell, I'm just loading the tokenizer. Then I go to next cell, I write my input statement. So these are the input sentences that I have. Now, these input sentences are going to be tokenized using these lines of code. So what do you see here? I have loaded a tokenizer from here and I put that into this variable tokenizer. Correct? Now I can use this variable tokenizer, give my data, and it will tokenize that using this particular tokenizer. Let's see how. So I have stored that into this variable tokenizer. I give my input statement, and in the next cell, you see here, I'm saying tokenizer, take my tokenizer, give my input statements, and then bunch of few other things, and it will tokenize that. it will convert my statement into IDs. Now let me just go through what it is doing here. It is doing a simple task. See, two statements are there. One statement is, let me copy this. You see, two statements. I hate this movie. First statement. This course is helping me learn new and wonderful things. Second statement. So first statement is now going to first be converted into tokens. So it is now, you see, I hate this movie. For this statement, this is the token being created from here to here. What it is, first number is for start of the statement. Where the statement is starting, this is for start of the statement. Then I hate this movie. 1045 for I, 5223 for hate, 2023 for this, and this one for movie. Then 102 end of statement. So here start of statement, here end of statement. But what is 0 after that? You see, 0 is coming because I have mentioned that you have to do the padding. What do you mean by padding? You see, second statement has more words. If you notice, second statement has more words than first statement. So second statement is being converted into these tokens from here to here. The input IDs, it is being converted to. So with the padding, we are making sure that add padding to the token so that all input have the same length. So the IDs for first statement and ID for second statement, all the statement which are there, their input IDs or their entire token is of same length. Same number of tokens should be there. For that, we are doing padding. It is easy for my model to work on it. So you see, I don't have any word further, but we are putting 0 so as to match the length of the second array that we have. Correct? It is only just to match there. Now, this tokenizer gives us two input. When we use the tokenizer, when I give my input statement to the tokenizer, it gives me two things. One is the tokens, the input IDs for both the statement. And second thing it gives us is something called as mask, attention mask. Second thing it is giving us something called as attention mask. What is attention mask here? Attention mask is going to be a guide for my model, for my NLP model. What it will guide here, it will say that, you see, in my first statement, the words are only from here to here. These zeros are the padded words, means they are not the actual word. We have just done the padding of it. We have just added extra zeros to complete the length of that, to match the length of first statement and second statement. But these are not words. These are just paddings. So you are just giving an idea to your model that you don't have to work on these. You don't have to spend your time, waste your time in studying these numbers. Your actual statement is from here to here, where the first one is your starting, second, last one is your ending, and the middle four are your words. So your words are actually present in the first 6 values, and after that there is a padding. So wherever in the attention mask 0 is written, it means that those are padded words, padded numbers. You don't have to see that. You don't have to waste time to study that. Correct? So this inputs that you're getting, this tokenizer is giving you two inputs. One is input IDs, one is attention mask. Correct? Padding is important. It is not that it is compulsory, but it is, if you do that, it is going to give you better results, faster results. Because when the length of both the inputs are same, then it performs a little better. It is not mandatory. You can say padding is equal to false also, but this helps in that case if you get the padding. So we always use that in the main cases. Now, if I want to see the attention mask and input ID separately, you see, this cell, there is no requirement of seeing them separately. There is no work of that. I'm just printing them separately. The input IDs I'm printing separately and the mask I'm printing separately. Just this code in this cell is extra thing. You see, this is the main part where you're getting your token IDs and attention mask. This part is just extra. I'm just printing that same thing here. Now, after that, I go to the next part where I mainly talk about the model. What we have done? We have taken the tokenizer, given our data, tokenized that, and got two things: input IDs and attention mask. Two things for now we have. Now, so when we go to the second part, model part, the input ID part we have done. Next part is the model. In the model, I'm using this particular model, TF auto model for sequence classification. This is a model I'm using, and I'm writing this particular code to load this model into this variable model, right? This is the name of the entire model from here to here, complicated name. So don't worry about that for now. Just understand that I'm using this model and loading that model into this variable here. I take this variable model and give my data to it, and it will start to make the predictions. So you see in the next cell, I'm giving model, take my model, give it the input IDs and give it the attention mask. When you give input IDs and attention mask, then it will start to give you logits. When you get this logits is not something which I want to directly use. Logits you get, then in the next cell, you use the softmax function to convert those logits into probabilities. And you see, this is giving the probability. Now you see, I am getting two numbers here and two numbers here. These are the probabilities. What exactly they might be telling us? So it is telling us that what is the possibility that my first statement, that there are two statements. So there are two rows of data you see. First row is talking about first statement. That what is the possibility that this statement is positive and negative? Positive and negative. Correct. First for positive and second for negative. So what is the possibility that your first statement is a positive statement, and what is the possibility that your first statement is a negative statement? When you add these possibilities, you're going to get 100%. Correct? You're going to get 100%. Right? So these two, when you add these positive and negative, these two numbers, you're going to get 100%, means 1.0 you're going to get. You can try these and you're going to get 100%. So out of these two, whichever is higher, right? Out of these two, I'm going to next cell and I'm saying that in these probability list, whichever is the maximum. In the first line, this is maximum. In the second line, this is maximum. So it means that first statement is whatever. I hate this movie. So I think, let's see. What was our first statement? First statement is, I hate this movie, right? I hate this movie and this course is amazing. So it means that these things are like this. Yes. So it means that it is negative and positive and negative and positive. So see, for the first statement, negative possibility is higher. And for the second statement, positive possibility is higher. So it is like this, negative, positive, like that. So whichever is maximum out of these two, we are picking that here in this cell. And in the last one here, we are saying that if the predicted label is 1, it means negative. Positive if the predicted label is 1, else negative. If the predicted label is 0, it means negative. If the predicted label is 1, it means positive. So you're getting this final answer sentence. I hate this movie. Sentiment negative. This sentiment positive. I've given a very basic broken down version of that. You go through it. As I told you, you don't have to remember this code, but this will give you an idea what is being done. Whatever I have explained in this figure, raw text given to tokenizer, get input ID. Input ID given to model, get logits. Logits given to post-processing, applied with the softmax, get the final prediction in the term of possibilities, and then you pick the higher one as your final answer. This same thing is being done with this code. Go through that one by one, all the cells one by one, you go through that, and you will get a good amount of idea about how the pipeline is working. Same way, the summarization is also done. Same way, those uh, sentiment analysis done, classification done, text generation done. Same processes are being followed for different tasks. With this, our task is completed. This is the practical part you need to know for transformers. Play with this entire thing, change the text, change the questions, play with that, and you will have much better idea regarding this. I've given this file to all of you. I'm giving this link again, and you can use this. Now, for prompt engineering, okay, I have one. From mobile, you can't download. Zoom does not give you option to download from mobile. It will be uploaded on LMS. From there, you can download. I'm giving a resource. See, this is the resource you have to follow. On this link that I've given, you scroll a little bit at the bottom and you exactly have to go at which one? Just a minute. Yes. If you scroll a little bit at the bottom, you will see this part, courses. And this is about applied LLM mastery. Whatever knowledge you have till now, with that knowledge, you will be able to understand all the things. It is dependent upon all the things being discussed here is dependent upon that. So here, first thing is, what is LLM? LLM is large language model, which is just an updated version of transformer. Whatever we have seen in transformer, the same way LLM work. LLM is large language model, just a modified or a scaled version of transformers. So you will be studying this. Then you will be studying prompt and prompt engineering. Here, the best possible prompt engineering concept you need to know is being mentioned here. So if you click on that, you will go through this thing, prompt engineering. How does it work? What is that? How you should be writing something. Everything is given with examples. So you will be able to understand each and everything properly. At least this part you should all go through. This is very important for all of you because you need to understand what set of questions to ask to generate a particular code, particular question, answer, and everything. This should be at least very clear to all of you. Then there is things like RAG model or everything. So one by one, you can go through the other things also if you want to go through that. But for now, very important, you go through this. What is the use of prompt engineering? You see, this is an AI tool I was using. So this question I've asked here, this question is called prompt. So your answers, which is given by any AI tool, is dependent upon how good you are asking a question. If your question is bad, you're going to get bad answer and you will be frustrated. Why I'm not getting the correct answer? Why is it giving so random responses? It is not useful for you. It is not the fault of this AI that you're getting wrong answer. It is fault of your prompt because it is not good. So prompt engineering will teach you how to ask good questions. If you learn